Dear students, welcome to the operating system video lecture sessions. Today we are going to discuss about process scheduling. So in process scheduling, we are going to learn about different process scheduling algorithms. Let me share my screen with you. So in this CPU scheduling lecture session, we are going to learn about the basic concepts, different scheduling criteria, and scheduling algorithms. The objectives of this lecture is to introduce CPU scheduling, which is the basis for multi-programmed operating systems, and we can apply various CPU scheduling algorithms. And you can also analyze the evaluation criteria for selecting a CPU scheduling algorithm for a particular system. Lecture outcome for this class is you can be able to apply process scheduling algorithm and calculate average waiting time of process using first in first out algorithms. You can also differentiate round robin priority scheduling algorithm and calculate average waiting time of different processes. You can also analyze the multi-level queue, multi-level feedback queue algorithms and compare single process scheduling with multiple processor scheduling. So the basic concepts of this process scheduling is generally when you start your CPU, generally the CPU will you are giving some task to your CPU. CPU will load and store that instructions and it reads from the instructions from the file. So by the time your CPU is busy, so that is called as CPU burst. When your CPU is working for your task, then it is called as CPU burst. When it is waiting for IO devices, input output devices, we call it as IO burst. Or sometimes you may save your files. By the time your CPU will write these contents onto that text file. So that is for IO wait. IO burst we can. Again, it will store the increments and it will increment the index and it will write to the file. This is again comes under CPU burst. When your CPU is waiting for input output devices, then it is called as again IO burst. So this process will continue. CPU burst, IO burst, CPU burst, and there are several cycles it will be happening. So all this is our main intention is maximum CPU utilization with multi-programming. Multiple programming can be done at a time and CPU must be utilized its maximum extent. So CPU burst and IO burst cycle with this process cycle, the process execution consists of a cycle and CPU execution and IO wait. Completely it's called as CPU execution and IO wait combinedly called as a cycle. So generally CPU burst followed by IO burst followed by CPU burst. Right. So coming to CPU schedulers. So there are short-term schedulers. These schedulers we have already studied in the previous chapters. Short-term schedulers, long-term schedulers, middle-term schedulers. So here in the CPU scheduler, there are some short-term schedulers. Selects from among the processes in ready queue and allocates the CPU one of them. So there is queue may be ordered in a various way as we have discussed in the schedulers, so short-term, long-term schedulers. There is different queues will be maintained waiting queue, ready queue. So there must be different queues will be maintained here. And CPU scheduling decisions may take place when the process switches from running state to waiting state, running state to ready state, and waiting state to ready states, or the process may terminate. So this in all these cases, CPU scheduling decisions may take place. What kind of scheduling algorithm we have to take? So scheduling under 1 to 4, whatever here it is 1 to 4, these cases the CPU scheduling is non-preemptive, and all other scheduling is a preemptive. So preemptive considers the access to shared data. It considers the preemption while in kernel mode. It considers interrupt occurring during crucial operating system activities. Okay. So then what is this preemptive and non-preemptive? Generally, there are two types of schedulings. One is preemptive scheduling and non-preemptive scheduling. So what is this preemptive scheduling? Preemptive scheduling allows a running process to be interrupted by a high priority process. Preemptive scheduling allows a running process to be interrupted by a high priority process. Whereas in non-preemptive scheduling, any new process has to wait until the running process finishes CPU cycle. Just like when you are in a queue, if a VIP comes, then the general people will wait for time sometimes. Then VIP will come and he will continue his process and he will go. So it is just like that. Non-preemptive means he will not wait. Preemptive means he will be interrupted. That process will be interrupted when the non-preemptive process arrives. So this is preemptive and non-preemptive. So the next one is dispatcher. So if there is a scheduler, then there must be dispatcher. So what this dispatcher will do? Dispatcher module gives control of the CPU to the process selected by the short-term scheduler. So it involves context switching. This you know, when you are switching from one process to another process, then it is called as context switching or switching context. Switching to user mode. So you are changing from kernel mode to user. And jumping to the proper location in the user program to restart that program. For example, there are 10 processes. The process 2, process 5, process 7 is completed. Then it must be make in a queue and it have to go for the next process, which is the right one. If this time takes when you are moving from dispatching from one process to another process, then that delay is called as dispatch latency. Time it takes for the dispatcher to stop one process and start another process is called as dispatch latency. Right. So scheduling criteria. So what are the different criteria to select the scheduling algorithms? First one is CPU utilization. Keep the CPU must be busy. That means then only you can get the maximum throughput. Throughput, what is meant by throughput? Number of processes that completes their execution per time unit. So within the specified time, how many processes it is completing, that is called as throughput. So always throughput must be high. So number of process must be answered, must be high in a particular time, in a particular certain amount of time. Turnaround time, amount of time to take and execute a particular process is called as turnaround time. Waiting time, amount of time a process has been waiting in the ready queue. So waiting time must be less and turnaround time must be high. Response time, amount of time it takes when a request was submitted until the first response is produced. So optimized criteria for the scheduling algorithms: maximum CPU utilization, maximum throughput, minimum turnaround time, minimum waiting time, minimum response time. These three must be minimum. Utilization, CPU utilization and throughput must be high. Then only we call that particular scheduling algorithm is a optimized scheduling algorithm. Now coming to the scheduling algorithm. So we are having several scheduling algorithm according to your syllabi. We are having FCFS, that is first come first serve, shortest job first, shortest remaining job first, round robin scheduling algorithm. So there are several scheduling algorithm. One by one we will see. So the first one is first come first serve scheduling algorithm. So here in the first come first serve scheduling algorithm, if there are n number of processes are there, which process will come first to the CPU, that can utilize the CPU first. So now we will take this one of this example, P1, P2, P3. See here, the main task of us is first come first. In the first come first serve scheduling algorithm, the process whichever come first will be served first. So let us take this example and we'll solve and we'll find the average waiting time. Our main aim is finding the average waiting time, and that must be less. Okay, now let us see this. So there are consider there are three processes. Let me take the pen. There are three processes: process 1, process 2, process 3. And first process will take 24 microseconds of burst time, and P2 will take 3 microseconds, and P3 will take 3 microseconds. This is the process, and this is burst time. Burst time, as we have discussed, CPU burst time, right? So remember, to find the average waiting time, first we have to draw the Gantt chart. So what is Gantt chart? Gantt chart is a combination of, it's a graph like time slice and the process. So let us take a line. So this is a timeline, and in this timeline will starts with 0. Remember, every in the Gantt chart is its horizontal line is its timeline, and the timeline will starts from 0. So first come first serve is our scheduling algorithm. So process 1 will take 24 units of time. 24 units of time. Units maybe it's in microseconds or nanoseconds or seconds, whatever it may be. 24 is a time. So process 1 will take 24 units of time in this Gantt chart. So it starts from 0, and process 1 will take 24 units of time. So this is P1, process 1, it will take 24 units of time. Then process 2 will take 3 units of time. So already in this Gantt chart, 24 units of time completed. From here, you take 24 plus 3, it is 27, that is occupied by process 2 for 3 units of time. The next one is P3, process 3. Already on the Gantt chart, it is 27 units of time is completed. So at the 27 units of time, P3 has arrived and it has completed its burst time of 3 units of time, that is 27 plus 3 is 30. Now we have to find waiting time for each and every process. So waiting time for P1. What is the P1 waiting time? How much time it has waited in the queue? 0, right? It has started at the point of 0. So it has not waited any time. So P1 waiting time is 0. And what is the P2 waiting time? P2 has arrived by 20 after completion of 24 units of time. So P2 waiting time is 24. And coming to P3. What is P3 waiting time? P3 arrived by 27 units of time. So P3 has waited till the 27 units of time. So P3 waiting time is 27. So these are the individual waiting times. Now we have to find the average waiting time. Average waiting time is equals to 0 plus 24 plus 27 by 3. It is 51, that by 3, that is equals to almost 17. So the average waiting time is equals to 17 units of time. So this is our output. So by using FCFS scheduling algorithm, this process, to complete this processes, it takes 17 units of time. So this is all about first come first serve scheduling algorithm. In the next lecture video, we will discuss about what is the drawback of FCFS and what is the next scheduling algorithm. The next scheduling algorithm is SJF. In what way this SJF is overcoming the problem from FCFS, that we will discuss in the next lecture. Thank you.